So we were discussing of direct combustion. Direct combustion of biomass in presence of oxygen or air to produce heat and byproducts is called direct combustion. When we can say combustion of biomass and in the presence of air or oxygen as that is, and out of this the byproducts are basically the heat we are getting as a byproduct, plus also we are getting some other food like ash or we can say unburnt particles that are also we are getting out of it. So this process is known as your direct combustion. So the complete combustion of biomass into ash is called incineration. So when we are completely we are when there is a complete combustion of biomass into the ash heat, biomass is converted into an ash, then the process is known as your incineration. Then the heat energy in the product gases or in the form of steam can be used for various applications like space heating or cooling. So the heat that we are getting out of this complete combustion of biomass is basically or in the form of we can use directly that heat in the form to heat this we can say space heating or cooling in that process, or we can use it also for power generation process, or we can use it in heating in industries or any other application like heating it for the we can say like we are heating in for something in a process like for ovens for baking for our purposes that we can use that heat in industry for heating purposes, or there can be any application like space heating, heating of homes, heating of commercial spaces, so that we are getting the heat that can out of this byproduct from the complete combustion is being used in the form of either in the form of heat or in the form of steam. Like if we generated in the form of a steam, we can use it to we can say to rotate a steam turbine out of this, and steam rotation of steam turbine will in fact trying to be able to rotate the steam turbines, and out of steam turbines we are getting this yeah power generation out of this. So, however, if biomass energy by combustion is used as cogeneration with conventional fuels, the utilization of biomass energy makes it an attractive proposition. So, what it says, if biomass energy by combustion is used as cogeneration, if we are using biomass energy by combustion and it is being used in a co-generation with another conventional fuels, like if we are using this co-generation with like first emission of steam, we can say we are utilizing the heat of the biomass to convert it, that heat is being used from the biomass, and then again it is being used in co-generation like in the thermal power plant, so that we basically what we are doing, we are taking off the load from the conventional fuels. Like if we are using biomass in conjunction with thermal power plant, so that means we are going for a co-generation of power. So we will be what we will be getting, like if we get 20% of biomass and 80% of thermal fuels. So what we will be having that we at least we are able to save 20% of the coal that has else have been required, else it has been the 100% requirement of coal for that particular power generation. But now in this case we are having like if we are using it in co-generation, biomass is basically the waste product. Otherwise that matter would have been gone for a wastage. So that part is being used in, that we can say the waste, that organic waste is being treated and it can be used for co-generation with thermal power plant, and that in fact is going to we can say we are going to save out of this the coal, we can say we are going to save the coal, or 20 to 25% of coal is being saved even if in a single plant. For that if we talk of like it will be going for 24 hours 24 hours a day, 30 days a month. So how much time it will be we can say how much the energy, how much the quantity it has been saved of the total coal has been reduced if we go for this use in a longer time. So like if we use biomass with cogeneration, it will be giving us a very best options for we can say preservance of this pure fossil fuels. Now what is this direct combustion? If we see, a simple biomass electric generation system is made up of several key components. So what are the components for this? For the steam cycle, this includes some combination of following items. So we have this is like with the cogeneration with the steam cycle. So we see this is a fuel storage and handling equipment, the first one. Then combustor furnace. Then third will be the boiler, and then the pumps, then the fans, then steam turbine. So out of that, generator, condenser, cooling tower, exhaust, emission controls, and then system controls that are automated in this case. So direct combustion systems feed the biomass feedstock into the combustor or furnace. So here if we see this is a containment structure, this is a pressurizer, this is a reactor vessel control rod, and this is steam generator out of this. Then it is in turbine, then it is in the condenser. So it is in the condenser again, it is power for the turbine for this part. So if we see, so this is a pressurizer and this is a steam generator, the fuel storage in this. The direct combustion of this biomass in presence of the direct combustion system fed a biomass feedstock into a combustor or furnace where we are feeding the feedstock into the combustor or a furnace where it is heated and where it is burned with excess of air to heat water in the boiler to create steam. So out of this we are heating it and we are getting, and this is a steam generator. Out of this we are generating steam out of it. So how we are generating steam out of it? We are taking up like biomass is burned with excess of air to heat water in the boiler and there is creation of steam. Steam from the boiler is expanding to steam turbine when it is made to pass to expand to the steam turbine. So when it is passing to the steam turbine, we will be rotating the turbine and in fact then it is coupled to the generator. When the generator is rotating, it is supplying the energy to the grid and from the grid to the home of us. So then steam is expanded to the steam turbine which runs a generator and produces electricity. So this is the upper one process we have seen like so far. So we are heating it and with pressure we are generating a steam out of it. The steam is made to expand in the steam turbine which gets to rotation of steam turbine. Then the steam turbine is coupled to the generator and generator is coupled to the we can say electric grid. From there we are getting to supply the electricity to our homes and commercial spaces. In general, all biomass require fuel storage space and some type of fuel handling equipment and controls. So if we talk of any of these biomass systems, it will require fuel storage space and some type of fuel handling equipment also. So we will be requiring fuel storage space is being required and the fuel handling equipment with controls with it. A system using wood chips, sawdust or pellets typically use a bunker or a silo for uh, short-term storage and outside fuel yard for larger storage. So let us take an example. If we are using your wood chips or sawdust or pallets, or then we have use a bunker or a silo. Then we have to keep it for storage. We have to keep it a bunker out of it here, or we have to use a silo for short-term storage. And if we are going to we can say we are to preserve them or we have to store them for a longer period of time, then and that too in a bulk quantity, then then an outside fuel yard is required for the storage of this. So depending upon this, we have a space requirement, or we use a silo or a bunker for this, because the storage of biomass is required for this, because if we need a continuous supply of the biomass for this, for the treating of it and getting the energy out of it. So we have to keep it in, we can say, in a storage for this, and that storage can be your silo, or it can, if it is for a short-term storage, and if it can, it will be the outside fully add storage for if we have to create, we can say, store it for a longer period of time, and we have to generate a, we can say, bigger amount of electricity out of it. An automated control system conveys the fuel from the outside storage area using some combination of cranes, stackers, reclaimers, front-end loaders, belt augers, and pneumatic transport. So what we see, an automatic control system, normally we see that is, and this is always required basically in this part, that is for conveying of fuel from outside. If we are taking the fuel from the outside, an automated supply system and automated supply chain we always we need for this. Because if we are giving it is we are having an outside yard fuel, outside fuel yard for this, and then we have to supply, or we can say convey that fuel on the outer storage area. Then we have to use the combination of, we can say, automated control system. It can be cranes, like cranes can lift from one place and keep the bulk into the usable area. From there it is being processed for burning or producing heat or anything. Then stackers also basically they keep the stacks of heap of this garbages or organic matter around them, so that can be easily collected over this. Then reclaimer is also basically the process that is used for shifting the equipment that is used for shifting the, we can say, organic matter from one place to another. Front end loaders are the loaders that load from the front part of this. They load a, we can say, reasonable amount of biomass into them, and then they use it to, and we can say, provide it to the platform where it is being used, and it can be used for further processing. Then belts, normally the conveyor belts we are known as, this is they are arranged by belt and pulley systems, they are arranged the conveyor belts for a longer distance, and they are being supported by at the bigger intervals by the pulleys or the rollers basically. So they are being used for supplying the, we can say, biomass from a shorter distance, like it cannot be used for very long distances, but still it can be used to convey within the plant. It can be used for, we can say, your belts can be used, conveyor belts can be used for transport of biomass from the storage to the, we can say, processing area. Augers are basically also they lift and can say set up that biomass from one place to another. Pneumatic transport is also basically the pneumatic transport is like pickers in this case that normally work on pneumatic power. So the pneumatic power, what it does, it basically keeps on to collect this all this from this part, and then they try to lift it, and then they lift it and drop it down to the you can see visible part, and that too very with a very less force there. So and the very less effort required for this. So that can also be an option for this. So we need an automated control systems for conveying the fuel in conjunction with direct combustion for direct combustion in conjunction with the storage of this biomass for longer or shorter period. So these are some of this. So next is a thermochemical conversion. If we